Hey, how's it going? Welcome back and welcome to lesson 2.2. I can draw particle pictures that show pressure differences. All right, let's get into it. When I think of pressures, I think of gas particles. And in the scope of our classroom, that is what pressure is going to be confined to, a gas particle. Something that we're going to associate with a gas particle to show pressure is going to be called a pressure vent. So we've talked about whooshies, and basically what a pressure vent is a whooshy that impacts the side of a container. As we can see, there's a ricochet occurring here. And basically what pressure is when a particle impacts the side of a container, we call it a pressure vent. At this time, let's formally define pressure for use in our classroom. Pressure is the impact of a particle of a gas particle specifically with the side of a container. As we look at the graphics here at the top, we see that as temperatures increase and decrease, that has an effect on a gas particle in a confined spot. Here to the left, we see whooshies that are quite small. The gas is definitely randomly kind of moving about. But as we see here at the top, as temperatures increase, these little ricochets that occur will be much greater and harder. Generally speaking, as temperature increases, energy will also increase, and in a confined container, the pressure vents will also increase. Due to the fact that there is more energy located in the container to the right container will have more pressure vents than the left container. So here, for example, we could draw one, and here we'll have two, as we've kind of shown before. Something else I'd like you to see is that, as a general rule of thumb, when things get hotter, the spacing also increases in between those items. If you've ever left a balloon in a hot car, what you might have noticed is that that balloon gets larger and larger with heat. So circling back to descriptor 2.2, how can I draw particle pictures that show pressure differences? Here's what we got to do, and you definitely want to write this down. Draw more pressure events. At this time, you'd want to pause the video and make sure you have everything written down and check yourself for understanding thus far. If you feel good as of this moment, we'll be kind of advancing this topic a little bit further to kind of see ahead down the road in chemistry. At this time, we're going to circle back to the idea that as temperature increases, pressure will also increase in a confined space. And what we're going to do is draw a highly detailed particle drawing that really explains this. So here at the top, there is an arrow that kind of shows us a spectrum, right? So as we get to the left, it's cold. As we get to the right, it's hot. And I have three particles in equal volume containers here at the bottom. And we can see that n equals 3 for every container, the number of particles will not change. So we'll go ahead and start with the first box here on the left. This is our coldest box. So what that tells us is that for these gas particles, the kinetic energy will be the lowest. So the amount of whooshes we want to give them is just 1, right? That signals low energy. Well, if the energy is low, we know that the pressure will also be low. So in this box, we're just going to draw one pressure vent. So here's a whooshy, here's a single pressure vent, and then there's going to be our third and final whooshy. Now let's move one box over. We're in a moderate temperature in between hot and cold. We know that the particles have gained energy. We'll give them 2 whooshies. We know that as energy increases in a confined space, the pressure will also increase. So this time we're going to draw 2 pressure vents. And notice that every particle now has 2 whooshies. If we now carry our attention to the right, this is our hottest box, which means it's our most energetic box. There should be 3 whooshies given to these particles. And what we should kind of realize is that we're going to have the highest pressure in this box, so we're going to have 3 pressure vents. So let's go ahead and draw that. There's 1, 2, and there's 3. To recap, and generally speaking, when gas temperatures go from cold to hot, in confined spaces, pressures will increase from cold to hot, as well as the energies go up. Let's go ahead and write this in a statement form, so now we can remember this through our notebook. So here's our key point. As temps move up, given same volumes and numbers of particles, the pressure will also increase. The pressure vents will increase. Please highlight this for yourself if you'd like. And know that this idea will be built upon in the labs that hopefully you're either going to do or have done in class. Thank you. Have a great day.